I have here an example. I've written it in C#. I've also written the exact same example here in C++. Let's go through the C# version and then we'll just glance at the C++ version. I have a base class. I threw an integer in here just so base would have something in there. Base has a constructor. When the constructor executes, the constructor will announce itself to the console. Derived is pretty much identical except it inherits from base. We threw a float in here instead of an int just for some variety. The constructor also announces itself, and then down here in main I say, hey, create a new derived instance. Now before I execute this, can you guess what the output will be? Pause the video before continuing on and figure out what the output will be before I Control F5 this. Control F5, run this, and you see the base class constructor executed and then the derived class constructor executed. Let's go to the C++ version. I have a base class, an int again. The constructor announces itself. Derived inherits base as the float. Constructor announces itself. And then here in main, I instantiate a derived, but I put it on the stack instead of the heap. This syntax says allocate an object, but do it on the stack, not on the heap. Control F5, the output is identical to the C# version. The base class runs before the derived class runs. Now here's the question I've been posing to my students, and the answers I get are actually a little bit disturbing to me because we're using machines here, very sophisticated computers, and yet the answers I've been getting back this week sound like there's some magic going on that really is not going on. And here's the magic question. Why does the base class constructor execute before the derived class constructor? Pause the video, see if you can come up with your own answer before continuing on and hearing me rant and rave on my religious soapbox. The answers I've gotten have been pretty similar to each other. The students have said, well, we need to create the base class portion before creating the derived class portion. And as a beginning programming student, I'm sure that many students would probably say the same thing. And in fact, their instructors have probably taught them that we have to create the base class instance before creating the derived class instance. But how many objects are we creating here? I'm creating one. And this constructor doesn't construct anything. In fact, I think constructor is a stupid word. I'm not quite sure how we started calling these constructors, but constructor is a stupid word. The constructor doesn't create the object. Let's go back to C#'s version here. I instantiate a derived object, but the thing that's actually creating the object is the new operator. All right, let me draw a heap out here. This is our heap. It's kind of like, well, let's think about America. When the settlers first came over, we had all this land out here, and they showed up and said, hey, let's start building homes and cities and buildings and doing things out there. But nobody constructed America. America was already there. It was just a matter of going into America and initializing it. All right? Let's go back here. New operator. New says, okay, I need enough room for an int. 4 bytes. I need enough room for a float, 4 bytes. Anywhere out here is fine. Let's just go right here. New sections off a piece of memory and says, okay, this will be the derived instance that we're creating out there. The top portion will be our int. That's 4 bytes. The bottom portion will be our float. That's another 4 bytes. So it may look like new just constructed an object, but new didn't construct an object. New allocated an object. New sectioned off a piece of memory here for the object. No object was quote unquote constructed. The RAM was already there. But then at that point you say, oh, well, the constructors execute. Aren't they constructing? No. A better term for these constructors, quote unquote constructors, would be initializers. Right? If we want to, inside of these initializers, we can set these values in here, this int and this float, to whatever we want to. We can initialize them to values, but no way, in no form, inside of this constructor or inside of this constructor are we, quote unquote, constructing, quote unquote, creating the object. The object was allocated. We got the RAM. It's up to us to initialize it in these, quote unquote, constructors. I shall call them initializers, at least for this video. We can initialize the RAM if we want to. Now this is .NET C#. The memory will already be allocated to 0, and generally 0 is a good default value, so we're not too concerned about it. In fact, right here, let me just insert some extra output right here. I'm going to say base, put a space there, plus me int, and then down here in derived, exact same thing. I guess I didn't really need to make new lines here, but I will anyway. Plus me float, Control F5, and voila, me int and me float are both 0. .NET automatically initialized this memory that we claimed or allocated to be 0. Let's look at the C++ version. I'm going to clear this off the screen. Let me add the exact same rough output in C++ version, though I'm going to say me int. And down here we'll say me float. Control F5, run that. Look at the output, and you see that me int is not 0, neither is me float 0. And the reason why this is because in C++, when you instantiate an object on the stack, you just get the bits and bytes that were already there. When people showed up to America, there were trees, rocks, and other things in their way, and they had to clear out the land. Same thing in C++, except instead of .NET clearing out the land for us, it's up to us to initialize these values. But these constructors did not construct the object. The thing that constructed the object in C++, let me draw a stack here. Just if you can picture it kind of going on a ways for that direction and on a ways for that direction. And there's stuff on the stack here prior to main. I'll say that the top of the stack is right here, but let me section off more of the stack. Each section here represents 4 bytes because 4 bytes is nice in computer land if you go look at my assembly programming playlist. But the stack goes on and on and on. Here's the top of the stack. We get into main. We say derive D, and the program at that point says, oh, all right, we need 8 bytes. Here's 4 bytes. Here's 4 bytes. Let's move the stack pointer from down here up here. And at that point, we have allocated our derived instance. But we didn't construct an instance. Neither did we have to execute any of these constructors, quote-unquote constructors, to create this instance. We just, in one full swoop, created the entire derived instance. We didn't create the base separately, and then the derived. We created the entire thing all at once. And then at that point, we say, well, let's let this quote-unquote constructor run. I'm going to call it initializer. Let's let this initializer run. And if the programmer inside of this constructor wishes to initialize this value, they may. Okay, same thing here with the derived. If we wish to initialize this value, we may, but we're not obligated to. And there's definitely no way inside a derived that we can allocate more RAM than has already been allocated. That's been decided for us by the program when we put derived onto the stack. So sorry to get so religious about this, but I'm not very sorry. These really should have been called initializers and not constructors. Now let me try to answer the original question I posed at the beginning of the video. Why does the base class constructor execute before the derived? That's because this derived, if you think about it, derived is appending or adding to base. All right, it's one object, but we're adding on to base here. And chances are inside of the derived constructor, I might rely on some state being initialized so that inside the derived constructor, I can use that initial state to do something intelligent. Let me see if I can demonstrate here. We already know we get garbage if we don't do anything with meint, at least in C++ land. .NET, thankfully, initializes everything to 0, but that's the best it gives us. That's better than what we have here, though. For an example, let's look at derived and say, you know what? For some reason in this contrived example that Jamie came up with, I want me float to have the exact same value as me int, but it will be a float version instead of an int version. So in the derived constructor, you can imagine me coming in here and saying me float gets me int. So I am relying on the state of my base class to already be initialized. And let's say that I'm a good author of the base class, and I say, oh, well, we better set up our initial state because derived classes might rely on that state. In fact, for the derived class to see it, don't I have to throw protected out here? I want to say me int gets 0. Okay, or maybe 50. It's a totally contrived example. I'm making this up. Let's say 50. And so I want me float to have the value of 50, but it will be a float instead of an int. And I'm relying on base to set up its initial state before my constructor runs. If it just so happens that the derived constructor executes before the base, I'll still have giblygop in here, and when I assign it to me float, I'll get the giblygop. But the language designers were smart and said, you know what? We should execute this function before executing this function, just in case the derived portion relies on the state being initialized. That seems sound to me. But I can get the exact same result by saying initialize. I'll put a void on it here. Void. Same thing down here. Void initialize. And then down here, I can say d.initialize. And then hopefully I'm smart in here. I say, well, base, please initialize yourself before allowing me to rely on your state. And if I control F5 this, let's look and see if we get the right result. Hey, look at that. Both values are 50. That's what we appreciate. That's another thing to think about constructors. That's probably another reason why we get so confused with constructors, is that they automatically execute when we instantiate an object. But constructors are not that special. Yeah, they don't have a return type. The return type's void. Don't tell anyone that. But we don't explicitly say a return type on side of a constructor. It just so happens the language is nice and says, hey, when you instantiate this object, I'll automatically call these functions for you. Right? Don't let your brain burn up when I say this, but a constructor is just a function. Nothing more, nothing less. It just so happens to be a function that is automatically executed when you instantiate the object. But in no way does the constructor create the object. Similarly, in no way does the destructor destroy the object. Constructors are there for us to initialize the state of the object. The base class constructors run before the derived class constructors, just so when the derived class constructors rely on state from the base class constructors, they'll get good values. Anyway, I've just been really bugged about this lately, and I wanted to clear the mud. We're working with machines here. I'll get off my soapbox, but there you go.